Hi, my name is Lou and I'm VK3AQZ. This is my latest project. It's a transceiver designed for use by the Foundation class licensees in Australia. Recently some of my homebrew transceiver articles were published in the Wireless Institute of Australia magazine, the AR. As a result of those publications I got contacted or had correspondence from some Foundation class radio amateurs. They are now allowed to build equipment, and they were wondering if did I have any designs that would suit their class of license. There are not too many DIY articles that they can build. Most were interested in building a transceiver with the specifications that meet the ACMA. So after putting all the comments together, this is what I came up with. This is a transceiver. It covers the 80 and 40 metre bands. They're the bands where the antennas are quite simple, and the 10 watts can be quite useful. There's plenty of activity on 40 metres during the day and also on 80 metres in the evening. 10 watts can get you a reasonable number of contacts. So here's a look at the front panel. It's an analog transceiver with the usual controls: tune, volume, IF, RF gain, AGC, fast, slow, audio and IF derived, 20 dB attenuator. It's the 80 and 40 metre bands each have their own tuned pre-selector, and this can be tuned with this little control here. There's someone talking there. There we go. Pick them up. And it also has the microphone gain control, a drive control, and also BFO. The BFO is digital. A bit of a conversation there on 40 metres at the moment. It's around about 7:40 in the evening. The VFO is an Arduino driven VFO. It's digital. It's got the usual functions, VFO A and B. It's variable steps from 10 cycles to 100 kilocycles. 9 memories. You can synchronise the two VFOs. You can receive on A and transmit on B. The display shows the power supply voltage and current, version number, the band and the mode, lower sideband, AM and double sideband. Up the top here we have a signal strength meter, power meter and SWR. The selections are made by a touch panel over here, so I can change, for example, well that's on 40 metres at the moment. I can go, that's on VFOA. I'm now on VFOB, which is on 7150, and I can change the band on VFOB, for example. I'm down now to 80 metres, 3650. Go back to VFOA. There's a station there. There's no fans or anything, so they really heat up. The BFO is variable on receive, but fixed on transmit. And it's also in it's digital and has a number of steps. That's 100 cycle steps. It's on lower sideband at the moment. Switch to double sideband. On double sideband it's an 8kc filter, so you'll hear a bit of chatter come up because there are two stations close together.
I tell you what, we went for a drive from Warburton East.
The tuning indicators, I've got little diamonds that move along as you tune. I'll increase the step distance. You see the little yellow dot, little yellow triangle. That now is moving in 10kc steps, and the little vernier with the little round dot is also moving in 10kc steps. Whenever I change the step size, those distances also represent the step size. The idea of this display is that I have a graticule down here, for example 0 kHz to 300 kHz, which represents the 40 metre band. So we cover 300 kcs. Once we go past that, the transmit OK light will come on saying you can't transmit. The idea of this is that this display can be replaced with a waterfall. At the moment I haven't done that. It needs a bit more processing power. But in the meantime this will be good enough. VFOB is the blue one, so if I go to VFOB, you'll see the VFOB vernier change, and again if I increase the step size so you can see something happening, you'll see not much down on 80 at the moment this time of night. It's still fairly early for 80 metres. I'm moving in 10 kc steps using the double sideband filter, which is 8 kcs wide. You'll see the no transmit lights just come on. Normally there's a CW signal there, I can just hear it. I'll go to lower sideband. It's just weak, it's from New South Wales, and later on in the evening that'll become quite strong. Go back to VFOA. Memories, memory 2. Now this on 40 we go up to 8 megs, which means there are broadcast stations, AM broadcast stations can be heard. Not much at this time of night. I think that's Radio New Zealand on this frequency. So, and we can go off through the 9 memories. Back to 40 metres, 7150. Sometimes this time of night I get South American stations. So that's a quick look at the transceiver itself. So now we'll look at the foundation class license requirements that's set out by the ACMA. This document you see down here is the one you need to use. It says Radio Communications Amateur Stations Class License, happens to be 2003. In this document under Schedule 2, it details the bands you're allowed to use and how much power. You're allowed to use 80, 40, 15 and 10 metres. You're also allowed to use 2 VHF bands, 144 megs and 432. The power is 10 watts, PX, which stands for peak envelope power. And over here it details a bit more about the bandwidth. You're allowed to go up to 8 kilohertz wide on your transmission. That means a double sideband A or AM. Can be quite wide, and you're allowed 1 watt of power density for 100 kilohertz. That would be for, say, digital modes or a mode that sweeps across the band. You're not allowed more than 1 watt for 100, or 1/10 of a watt for 10 kilohertz, or 1/100th of a watt for a 1 kilohertz bandwidth. So you need an instrument that can cover a certain bandwidth, measure the power, and you have to be below that figure. On 10 metres you're allowed a bit more bandwidth. I think you're allowed FM up there on 10 metres, parts of 10 metres, so they allow you up to 16 kilohertz. Again, the power density can't be more than 1 watt per 100 kilohertz. And there's no limitation on bandwidth on the VHF bands at all. Now, one of the requests I got, or several of the requests, were this transceiver project needs to be highly educational in such a way that whatever they learn can help them get up to the higher class of license where they can run a lot more power and a lot more bands. In the ACMA Recognition Certificate syllabus and examination information, they're looking for specific knowledge from the foundation class candidate. For instance, under Transmitters and Receivers, section 4.1, block or concept diagrams of simple transmitters and receivers, they want you to identify, using the block diagrams they give you, the names of the stages in a simple transmitter and receiver. So this transceiver has been designed in modules, and I can show you the internal looks of that. So the educational component of this transceiver has to enable some of these students to understand what each block does. My articles in the Amateur Radio magazine of the HF transceivers were of modular form. The modular form allows you to remove a module, modify it, change it, improve it, whatever, rather than one large circuit board. Also, a lot of the requests were, we don't really want to see a lot of integrated circuits if possible, just transistors, and certainly no PIC chips or EPROMs or anything that's programmed. Some of these people have bought kits with PIC chips and EPROMs. They may have damaged the PIC chip, but they're not really sure. Once the PIC chip's damaged, it can't be used. They go back to the supplier, they no longer exist, or it's been copyrighted, and so the small QRP rig or whatever DIY project they made goes into the scrap heap. So their requirement was to make the circuitry simple, a simple analog, easy to understand. Other amateurs that can help them, that providing it's not too complicated, they may be able to help, and so on. So they were the conditions that were set down when I designed this transceiver. Apart from the power limitations and the bands that a foundation class can use, all amateur class licensees have to observe the level of the spuriouses coming out of the transmitter as fed into the antenna transmission line. You're not allowed to go over 43 plus 10 log PEP power, which would be 10 log 10 watts, for example, for the foundation classes means that's 43 plus 10, so it's either 50 dB or 53. If you're running 5 watts, instead of 53 dB down, it can be 50 dB down. If you're running 2 watts, it can be 46 dB down. However, nonetheless, the spurious must be minus 53. This transceiver has been designed to meet that specification. It's got a 454 kCIF, which means that the image is only 910 kcs away. So the filtering inside has been designed to make sure that we go below the minus 53. I did make a demonstration. I have made a demonstration of measuring the spurious on an oscilloscope and also using a good quality receiver tuned to the spurious frequency. Some of the requests ask for a Bluetooth. I've got a Bluetooth module here which I'm experimenting with. This particular module is connected to the output of the transceiver. There's some connectors at the back. You'll see the little Bluetooth module there. It also has infrared, an infrared controller, so you can turn the transceiver on to transmit remotely. I'm using infrared, which would go in parallel with the Bluetooth. The Bluetooth audio from your microphone will go to the transceiver. At the same time, Bluetooth out of the transceiver will go to a set of headphones. This is just a lash up. It does work, and I can demonstrate that into a Bluetooth speaker or something later on.
I know it sounds odd, but the questions there's more of them, but they're a little bit easier. So that's what I've just done. I got
There's a bit more signal on 40 meters. So here's an example of the Bluetooth. It's just coming to this little speaker. It's a Bluetooth speaker. I can vary the level here.
and it was one of the best Christmas.
There we go.
Yes. And I don't like Christmas, but I wouldn't trade.
So that's the receiver sending a signal through the Bluetooth module to this Bluetooth speaker. You can, of course, you can also use a pair of headphones like that, Bluetooth headphones, and maybe a box that you make. This is the remote transmit, so I'm just going to go to dummy load. I don't want to cause a problem. I've just switched to dummy load, and this is the transmit controller, the infrared. So we've got there we go. We're now in transmit mode, and now we're out of transmit mode. So this little infrared, quite cheap little module actually. Transmit, receive, transmit, receive. You can just see the little module down here. It's got its own little LED. Transmit, receive. I also have an infrared detector on the front of the rig. This is for future remote controls. This is to be driven from a TV remote, and the infrared codes will be sent to the touch panel, and they can be, you can use the TV remote control to select all of these functions plus extra ones which can be added to the TV remote control. So that's a quick look at the transceiver. I'll show you some inside views later and some measurements I've done on intermod distortion and also on the image levels. A few other little things in separate videos, otherwise they get a little bit too long, these presentations.